All right. Sorry this is coming out so late. Just trying to figure out stuff. I'm at school actually. So I wanted to use the document camera. So that's what we're going to look at today. So we're going to start. This is for section 10.1, an introduction to surface area and lateral area. So I'm going to share my screen with the document camera here. Look at that. Okay, so you should have this chapter 10 test guide and you should print it out. It's available on Moodle. And so we're going to go through the notes today. So, all right, so first of all, what is lateral area? Lateral means side. So let me give an example here. Kleenex box. So when we talk about surface area, we're looking at three-dimensional figures. So here's a Kleenex box. And so when we talk about lateral area, we're looking at the area of the four sides. So there's the four sides. So this is top, this is bottom. We don't count that lateral area. We're just looking at the four sides. Okay, now if we had a cylinder like this can, it's not a perfect cylinder, but I don't have one. For a cylinder, the lateral area is this part of the can here, not the top or the bottom, just the side, so to speak, of the can. All right, so going back to our sheet, so you can fill that out. So then surface area is the four sides and the bases. So in our Kleenex box, it would be all six bases added together. With a cylinder, it's going to be the two bases, the top and the bottom, plus the lateral area. So for a right prism, so that's something like a Kleenex box, because the sides meet at 90 degrees. For a right prism or a cylinder like a can, the lateral area formula is the perimeter of the base times the height. So by P we mean perimeter of the base. And that gives you lateral area. So here it says, what is the lateral area of a right cylinder with a height of 6 and a radius of 4? So you can pause the video a second if you want to try it yourself. I recommend that. So first of all, for a cylinder, remember that, so you can get my really terrible drawings again here. Cylinder. I shouldn't, well, whatever. Okay. This is supposed to be the front, I don't know, whatever. Like I said, bad drawing. So in a cylinder with a radius of 4 and a height of 6. So the perimeter of the base of a cylinder is equal to 2 times the radius times pi, or pi times 2r. So in our case, it's going to be pi times 8. That's the perimeter of the base, right? The circumference. And then to find the lateral area, we need to multiply that by the height, which in our case is 6. So you get 48 pi. And that would be centimeters square, because we're talking about area. And so the units would be square. Okay. So if we look at our Kleenex box, if you want another example here, So if we wanted to do lateral area here, first we need the perimeter of the base. So take out my ruler. We'll do this in inches because we're American. So we're at 4 1/8 for the width. So 4 1/8. And then for the length, hopefully you can see that, we're at 8 1/4. All right, so then perimeter. So we have 8 1/4, 8 1/4, that's 16 1/2. And then we got 4 1/8, 4 1/8, that's 8 1/4. And 16 1/2, 24 3/4. That's the perimeter of the base. Hopefully I'm doing this right. I don't have you here to help me. 8 1/2 and 16, sorry, 8 1/4 and 16 1/2. All right, so that's the perimeter of the base. Then we need multiplied by the height. So the height is 4, sorry, that was in centimeters. The height is 1 inch, and we're going to call it 1 3/4 inches. Okay, so we'll do that here. Hopefully you can see this. 24.75 times 1.75 gives me 43.3125. So that would be the perimeter, or sorry, the lateral area of this Kleenex box. Hopefully that's what you would get too. Another way you can find lateral area is if you took the area of each of the 4 rectangles here and added them together. That's a bit more cumbersome, but it'll get you the same result. So just to show you that, so we know that this side here is 4 1/8 by, what did we say the height was? 1 1/4. Sorry, 1 3/4 by 1 3/4. Sorry, put that where you can see it. So if we do that, just plunk it on my calculator here a sec. That gives us 7.21875. And we have 2 of these, right? We have this one here and this one here. So if I multiply it by 2, I end up with 14.4375. And now this side here, we know is 8 1/4 by the height, 1.75. So if we do that, we get, interestingly, 14.4375, and there's 2 of these sides, right? This one here and this one here. So if we multiply that by 2, we get 28.875. So if we take 28.875 and we add it to the 14.4375 from the other 2 sides, we end up with a total of, I want to write it there, 43.3125, which is what we got by doing the perimeter times the height. So understand that perimeter times height is just a quicker way of finding the area of all 4 sides, right? Because if you look at it algebraically, you're going to have, looking at the, you've got your sides that look like this, right? So this is height by length, height by length. This is height by width, right? Those are the four sides. And so to add them up, you'd have WH plus WH plus LH plus LH, right? And so using the distributive property, we can rewrite this as, we can factor out this H. And so we'd get H times 2W plus 2L, right? Because W plus W is 2W, and L plus L is 2Ls, and the H is in every part, so we factor the H out. Because this could be written as 2WH plus 2LH, which is actually how we figured it out. But what is 2W plus 2L? Well, that's actually the perimeter, right, of a rectangle. It's actually the perimeter of the base of this Kleenex box, right? Because you have L, L, W, W. We say the perimeter is 2L plus 2W. So that's how we get from finding the area of every every side, and we get to a formula, which is just what we have up here, perimeter of the base times the height. So hopefully that makes sense. Now going to surface area, we just add the bases in. So the general formula is perimeter of the base times the height plus 2 times the area of the base. Right? And a box, so a box is a special type of right prism. Okay, they're very common. So just to note, the formula would be 2LW plus 2LH plus 2WH. So let's look at the example here. And again, you can pause it here a second if you want to try this yourself before you watch me do it. So this is not volume, right? So we're not just multiplying these three together. That's not correct here. We're looking at surface area. So one way to think about it is you can draw what's called a net. And obviously I'm bad at drawing. And this is not going to be to scale because why would it be? Okay, now I'm going to have to cross over the line here. I know, not ideal. Hopefully you can still make it out though. Okay, so if this is my base right here, the very bottom of my box, I didn't do that right. Ignore picture. Let me draw it over here. I wanted to draw it over here anyway. So I'm gonna say this is my base. I've got my two sides. Then this would be the top. Then I just, yeah, so I did it right over there. I just didn't have the room I wanted. Okay. So in our case, we have 7, 8, 9. Maybe I could have made the dimensions a little nicer. But we're going to say that the length is 7. So that would be here. The width is 8. That would be here. And then the height is 9. So that would be here and also here, right? Because we're folding this up. So I don't really have a great example here. Maybe I'll rip it up a box, kind of show you what this would look like. So here's a net, right? So here's my base. We're going to call it base. And then what's different here is that these flaps are gonna have to be put together. So here's a side, right? And then we have the top that folds up. So it makes my box again. And then obviously the flaps. So it's not a great example because in order to be a good net, this would all be together and either and open up on one side or the other. But you get the idea how a net would work. Let's go back to our note sheet here. All right, so then surface area is just finding the area of every one of these faces and adding them together, right? So 7 times 8, 56. This here is 7 by 9, that's 63. This is the same as the bottom, so that's 56. My sides are 8 by 9, that's 72, 72. And then this here is the same as this side here, so 63. You could add those all together. So 72 plus 72 plus 56 plus 56 plus 63 plus 63. Right, gives me 382. Now obviously it's much faster if you use the formula. I'm just showing you how we get to the formula, right? Because here's length width, here's length width, so 2 length widths. Then you got 2 length times height. That's your side right here, right? Length times height, length times height, that's the 63. And then width times height are your 2 sides over here. So using the formula, we would do 2 times 7 times 8 plus 2 times 7 times 9 plus 2 times 8 times 9. There's my 382. And so we're still dealing with area. So our answer is going to be in inches squared. So hopefully that's what you got when you tried it. And then the cube surface area formula, in a cube, remember the length, width, and height are all going to be the same. So you're going to have, thinking of a net of a cube, and obviously there's subtle variations to how you can draw a net. Okay, so thinking of a cube, if your side of your cube is S, right? So that means maybe if I write in cursive, so it doesn't look like a 5. So every side of no, it doesn't look like anything. We'll write it again down here. Okay. If every side of your cube had a length of S, then the area of every face is going to be S squared. And since there's 6 of them, the area formula is 6S squared. Okay, so there's the introduction to lateral area and surface area. Here's the homework I expect you to do from your textbook. Notice this is section 10.1, and we'll see how that goes. Have a good day. I miss you too.